Hi, we are Engineering Brothers and we are having our another consideration over here. In our left hand side, we are having our considered number of poles or the what seems to be the nature of poles in our S-plane over there. And in our considered point, the roots are located at our plus minus of sigma over here. And we are having our two different set of consideration when if we do put the poles at s is equal to minus sigma, quite naturally the multiple roots over here, you can see that there are lot of numbers of poles that are located at our s plane over there, and in our s plane only two poles are there, but there are multiple poles are there. Because of that, the series of our consideration of a1 plus a2t plus dot 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 akt to the power k minus 1, that has been given over there, and this is our mathematical expression. The same procedure over there. First of all, we are having our transfer function, which is cs by rs, and in our next stage we should consider the input as our impulse response over there. So rs will be 1. Then cs do have the series expansion for our Laplace transform over there, and how to consider the s domain into time domain over there, just by applying our inverse Laplace consideration to have the final equation, which is this one. So here you can see that we are having our two CT equations over there, and this upper portion is for our the multiple poles that are placed at the same point of s is equal to minus sigma over there, and the multiple poles are placed on that same points over there. And in this case, if you just do consider the s plane consideration, here this is going to be our minus sigma over there, and there are multiple points that has been considered over there. Now whatever may be the value for this plotting, whether you can choose the minus 10, minus 9, minus 8, there are a lot of points are there, whatever may be the points over there. So this is quite naturally the generalized format to have the final analogy over here, and quite naturally you can see that the ct versus time will be this one. Why? Because of this e to the power minus of sigma t format over there, if you just do increase the time, the oscillation is dying with respect to time over there, or it is decreasing with respect to time. So quite naturally this one will be a stable system over here. Why? Because if you just do increase the time, the oscillation is going towards our zero over there, and there is some tendency to have the finite value over there. That is why this is going to the finite value over there, and because of that consideration we can say that the system is stable. But in our this is going to be our upper consideration over here. Now I want to repeat this question once again. For our s is equal to minus sigma over there, the mathematical equation will be this one, and I no longer do require to consider the same sort of steps over there, as I have already given you all those crucial steps over there, and this is going to be a mathematical expression over there after we have followed up on that multiple roots on that same points over there. And here the plotting of that multiple poles are considered over here, and in our extreme right hand side we can see that we are considering our output response with our given system of ct versus time over there. And if you just do increase the time, the oscillation is decreasing. You can see that in our previous consideration, or in our starting point, this is going to be the greater one, and if you just do increase the time, it is been going just like this way. That is why it is the value of this overall ct that is going towards our zero over there. So that is the definition for our considered ct versus time over here, and we can say that the system is stable. Now let us just move on towards our next part, which is the multiple poles or roots. The multiple roots are placed at our s is equal to sigma over there. For that one, the mathematical expression will be this one, and this is the s plane plot over here. Just by looking at this S plane, we have configured the CS by RS over there, and after that CS by RS, because of that considered point over here, we are having our multiple locations of the poles that are associated over here, and quite naturally in both the equation for a mathematical expression, the k is the number of roots. And what is the number of roots? If you are considering that k is equal to 1, then one root will be present in our given diagram. If you just do consider 5, then 5 roots are considered at the same point of our S is equal to sigma over there. And this is going to be a S plane over there. And if you just do plot this CT expansion over here, we are having this plot as our CT versus time over here. And after looking at this graph of our CT versus time, we can make the comment on this given diagram over there. And if you just say that if you do increase the time, or time t tends to infinity, then the oscillation is increasing. Okay, now in this, accordingly, in this curve, you can see that the oscillation is increasing with respect to time. That is why I can say that this waveform actually gives us the unstable scenario or unstable system characteristic over here. So this is the definition for these two type of systems over there. Though I want to say another thing over here. As you can see that the poles are placed at the left hand side of our given S plane, we can say that this is going to be a stable system over here. And this is the another analogy over here. As you can see that the CT curve is going towards our 0 over there, and that is the another analogy to say that this system do have the stability of this system is stable. And in our lower part, you can see that the multiple poles are placed at the right hand side of our given S plane. Now quite naturally we can see that this is going to be the oscillation, or if you just do increase the time, the oscillation is increasing with respect to time. That actually do give us the unstable characteristic or unstable nature of the system over there. Now this is the next step consideration. In this video, we are considering the multiple roots that are placed at the same points over there, and if you just do change the position of that poles, then the definition of our stable or unstable thing will changing with that. If you just do placed the poles at the left hand side of our S plane, then the system is stable. And if you just do the same thing in the opposite direction, which is right hand side of our S plane, then we are having our unstable system over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel. That's it. Thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.